So we're talking about arrays. An array is a sequence of values. Easiest way to think of it. It's a series of values. So with one variable name, we can access a whole bunch of data rather than just one piece, rather than just age equals 7. You could have an array of ages and you could store 10,000 ages in that array. You think I'm kidding, but let's see how large of an array we can actually allocate. We're not going to actually mess with doing this for too long, but I'm going to try creating an array with 100,000 elements in it and see if it complains about it. We are on project elemental PQRSTUV. It's a new project, lecture V. Grab the boilerplate, file new. All right. So the syntax for declaring an array is data type, name, array name, followed by the subscripts, and X, length, where that is the length of the array. Let's make an array of ints called nums. Int nums, and it's going to be 100,000 items long. And we want to initialize them all to the value of 0. We haven't played with initializer lists much yet, but if we do this, what that says is set the first value equal to 0. And then, since we didn't give any values for the other ones, they'll all also be set to 0. Now, that doesn't mean that if we set this to 1, it'll initialize every element in the array to a 1. Instead, it means set the first element to 1, and then the rest of them will all be 0. See, that works. If this number here is larger than the number of elements in the initializer, then the ones that are not specified all get filled in with zeros. So this would mean that the first element gets assigned to 1, and then the rest are all zeros. Whatever. Let's write a loop that'll add up all those values. Just see how long it takes us. So double total equals 0. And we could use an index-based loop, or we could use a value-based, a for each loop. Let's use an index-based loop. For int I equals 0, subscript I less than. Now see, here's where I should be asking the array for how big it is. And I didn't. So I'm going to come back up here and I'm going to declare a constant to hold that 10,000. It's just going to be called array size or nums size. So const space int space nums underscore length equals 100,000, 1 followed by 5 zeros. And then instead of using 100,000 there, I'm going to use my variable name, nums underscore length. And I will paste that there. And lastly, I will also paste that there. Okay. So for int I is equal to 0, I less than nums underscore length, semicolon, I plus plus, I short for index, total plus equals nums subscript I. And since our first element is equal to the value of 1 and all the rest of them, all 999,000, the rest of them are zeros, it's only going to equal 1. But I'm just curious about how long it's going to take for us to display this. Total equals, comma, end quote, for total equals, end quote, arrow, arrow, total, arrow, arrow, ENDL. We're going to find that it's pretty dang fast. Computers are fast nowadays. The time it takes to compile it is infinitely longer than the, okay, yeah, see, it added all 100,000 numbers in the blink of an eye. What if we make it 1,000,000? Will it support 1,000,000? I just added in an extra 0 there. All right, Stack Overflow. We used up too much RAM. Since each int is 4 bytes, the program was trying to allocate with one call 4 megabytes of information. Now, there are some things we could do that would actually enable that, but I was just kind of curious as to how large we could go before it would complain. So that didn't work, so I'm going to click the little red stop up here.
When you say use too much RAM, is that based on how much the program is allowed to use, or based on how much RAM you have in your computer?
It's not based on how much RAM is in your computer. It's based on, by default, how much memory is being allocated to that application. And there's a way to modify the settings of your compilation to give it more stack size. But I can't explain that in 2 or 3 clicks, so I'm not gonna. But we would have to go out and we'd have to find the setting where we specified the stack size for the compiler and then told it, nah, we're going to be dealing with large data sets. We need to be able to access more than 4 million. So I'm going to change that back to 100,000. What if we wanted to fill that full of random numbers? I don't know. That almost sounds like a homework assignment. Almost be too easy to do right now. Let's remind ourselves, somebody remind me of the name of the library in which the random number function is in. Is it STD LIB, standard library? C++. Yeah. So yeah. But I thought there was a better way of doing that. So it's part of C standard library. All right. So yeah, we're going to fill our array up with random digits. So # include angle CSTD LIB, close angle. Now they're not going to really be random numbers because we're not going to take the time to set the seed value. So the seed's always going to start at 0. So every time we printed these out, they would be the same random values, which isn't very random, right? But the same sequence, but that's okay. So we're going to need an array that will go through and let's just change that to 0. It's bugging me to see that. We're going to need a loop that's going to go through and set all the values in the array equal to a random value. So for parentheses, int I equals 0, I less than nums underscore length, semicolon, I plus plus. And by the way, that was a really good question about the memory. Nowadays, modern operating systems use what's known as virtual RAM so that their amount of physical memory in your computer does not really dictate its limits because it's spooling memory out to disk and then reading memory back in from disk as it needs to so that it can pretend it has a huge amount of RAM available to it even if you've only got like 2 or 4 gigabytes installed on it. That's what that page file .sys file is. If you've ever noticed that you have a huge file sitting in the root of your hard drive. Oh, it's not going to show it to me. It's a hidden file probably. Anyways, it'll be set to the amount of RAM that your computer thinks that it needs to emulate, 8 gigabytes or something like that, a page file. And actually, no, I just lied to you. Forget everything I said about that. The page file is what's written to disk when your computer goes to sleep, I think. I'm going to stop talking like I know what I'm talking about. All right, so here we go. For int I is equal to 0, I is less than nums length, I plus plus, swap file. Swap file.sys is the one that I'm thinking of. Nums underscore I equals REND, parentheses, in parentheses. And let's say that we want numbers between 1 and 1,000. So what we're going to have to do is to do mod 1,000 like that, but then add 1 to our result. If you wanted it to be between 1 and 6, you just change the mod to 6. Now our total is going to be significantly different, right? We're going to actually have data in there. But still, it didn't take any time to add that up. 40 million, 49 million is what the total consisted of. Why don't we print out the first few digits in our array just to see what it looks like?
I'm getting a syntax error for some reason. It's saying my I is undefined. I don't know why.
Do you have INT in front of it there?
Yeah, I got that.
Do you have a semicolon right here?
I do.
Yeah, take that semicolon out. If you put a semicolon there, remove it. Those are like if statements. If you put a semicolon after the end of the for syntax, it breaks it. That fix it? All right. So let's print out the first, I don't know, 40 elements of that array. And the first 10 will do, right? So for parentheses, let's add a comment as to what we're doing now. Print the first 10 elements of the array. Yes, thank you for shutting that. For int I equals 0, I is less than 10 because we just want to count up to 10. For int I equals 0, semicolon I less than 10, not greater than, I plus plus, cout, arrow, arrow, nums, subscript I, arrow, arrow, quote, space, quote, in semicolon. Now I'm trying to print them out all on one line, and so that's why I did not use ENDL. But once the for loop is done, we want to go to the next line. So after that closed curly brace, cout, arrow, arrow, ENDL. I just want to see what our random data looks like. And there they are. When you run it, you'll probably see the same thing. I bet your first random number is 42. Does that seem to be the case? Yeah. Okay. I'm going to go back and add a few more comments, like what are we doing here? Fill the array with random numbers. 0 to 1,000. And then this code down here calculated the total. Calculate the sum total of every element in the array. But sometimes you want to search an array, meaning you're looking for a specific value in the array for whatever purpose. Maybe we want to find if anything is equal to the number 13 because we don't like that unlucky 13 and we want to change it to a 12. This is just silly. But let's go ahead and write something that'll do a linear search. So way down here, what is a linear search? It's where we start with element 0. We say, hey, are you 13? Nope. Go to the next one. Hey, are you 13? Nope. We go to the next one. Hey, are you 13? Yeah, we found it. Okay, and then we stop. That's called a linear search. Now, if your data is sorted, you can do a more efficient search where you guess halfway in the middle, like between, if you have a list that's 100 elements long, you look at the 50th element. And is that not right? Okay, well, you jump back half, just like that guessing game. I'm thinking of a number between 1 and 100. 50. Nope, that's not right. 75. Nope, go lower. And then halfway between 50 and 75, you can keep zeroing in on it. It's called a binary search because you're breaking it into 2 each time. We're not going to do a binary search because this data is not sorted. The only way you can do a binary search is if it is sorted. But anyways, let's write a linear search. Our target value that we're looking for, we want to find a 13 in it. I just picked that completely random. And so now we're going to have an index value which indicates whether the value is found or not. I'm going to just call it found at. Int found at. and I'm setting it equal to -1, that's going to be our key, our indicator, our sentinel that it was not found. So if after we go through the loop, if found that still equals -1, then we never found it. So for, and yet again, int I equals 0, I less than the number of arrays, I've forgotten the name of that constant, nums underscore length, semicolon I plus plus. We're going to check to see if that particular value at that specific index is equal to our target. If nums subscript I in subscript equals target, we found it. Curly brace, cout, found, end quote, arrow, arrow, in target, arrow, arrow, quote space, at index, end quote, arrow, arrow, I, arrow, arrow, ENDL. And so now let's put that found at variable, found at, and set it equal to I so that we know we did find it. Found at equals I. We're just taking note of which position in it. Like we were searching in an apartment complex for a convicted felon on the run. We open every door, we finally find him in apartment number 234. We're happy to know about it, so we keep track of it. So after our loop is done, we can check to see whether found that still equals -1, and if it does, we never found it. So if found that equals -1, close parentheses, curly brace, cout, target space, end quote, arrow, arrow, target, arrow, arrow, quote, not found, \n. Else, cout, arrow, arrow, target space, end quote, arrow, arrow, target, arrow, arrow, quote, found at index space, end quote, arrow, arrow, found that, if I could type, found at, arrow, arrow, ENDL. All right. Now it actually found a whole bunch of 13s. I guess that's not surprising. We have 100,000 generated numbers, all of them between 1 and 1,000, so 13 occurred a lot in it. What if we only wanted to find the first one? What if we wanted to stop right here at position 1037 and not keep going for efficiency's sake? I can think of two possible changes we can make to our for loop, but I'm wondering if anybody else can come up with one. Here's our linear search loop right here that is searching from beginning to end. When we find the array, when we find the target, we set the found at equal to the index. What else could we do now to stop searching at that particular point?
Could you scroll down to the else?
I sure can. Exactly, we'll break. We're going to put a break statement here so that we don't need to keep searching. So after found at equals I, we're going to break to exit the loop. Don't need to keep going. So break, semicolon. Now should only find one occurrence. 13 was found at index 1037. Guess I don't need the words hello world anymore in my program. All right. Anybody got any syntax errors that you would like? English. The reasonable thing to do would be to make this a function, right? There's no real reason every single time you want to search for a specific value to rewrite that loop. Does it work for you?
No, I'm doing something.
All right. So we should probably turn this into a function, but rather than copy and paste it, I'm just going to rewrite it. Pardon me, does anybody else have syntax errors? Somebody said something. I swear I heard somebody say something. Okay, so we're going to write a function that does a linear search. I'm just going to call it linear search, and it's going to return an integer. So here's what our function looks like. int space linear, well, if I could spell linear, it would help. linear underscore search. We need the array name, so I'm just going to call it AR for array. In AR subscript, in subscript. We also have to know the number of items to search. So int length, comma, and then the target we're looking for. Int target. Now it's going to be the same kind of business. We just declare a variable called foundat, and at the bottom of the code we're going to do return foundat. So int foundat equals -1. The bottom line of our function had better be return foundat, but between those two lines is where we're going to put our loop. For same business, for parentheses int I equals 0, I is less than length, semicolon I plus plus, curly brace, if parentheses nums subscript I equals target, close parentheses, open curly brace, foundat equals I. And we could either do a break or we could just do a return right here. But just to make our logic look exactly like the other one did, I'm going to make it a break. And I'm sorry, my array name was called AR, and I suddenly started calling it nums again. So I replaced nums there with AR. And let's write a description of what this function does. Searches array AR for the target value, returns the index or -1 if not found. We actually do in this language. We've seen ways of calculating the length of the array. let's play with that a little bit. Well, let's make sure this compiles. All right. We have seen that we could get the length of an array by doing something like this. Int size equals size of, parentheses, nums, in parentheses, divided by size of, parentheses, nums, subscript 0, in subscript. Right. We've seen that that works. We could print out the size of the array right there. Print out, quote, array length equals, end quote, arrow, arrow, size, arrow, arrow, NDL. But this only works if you're in the same context in which the array was allocated. And this is a quirk of this language, and it's not true of C++ or Java or Python or umpteen other languages. Okay, so the array length is equal to 100,000, just like we said. But if we declare a function that's supposed to like calculate the size of the array and return it or whatever, int get size, parentheses, and we're going to take an array, int nums, square brace, close square brace. Now this code's not going to work. Let's pretend it's going to though. Int size equals size of subscript nums in subscript divided by size of parentheses nums subscript 0 in subscript.
Do you want us to type in that? Or is this
Well, this is not going to work, so I don't care if you type this or not. I'm going to wind up commenting it out or something like that to get rid of it. And then return size. And when I try to run it, well, I didn't call it. Let's try calling it. Size equals get size, parentheses nums. And let's print it out. So I guess just copy and paste that line here. I was hoping it would actually generate an exception, but what we see here is that it says the array length is 1. You cannot use the size of trick to calculate the number of items in the array unless you're in the same block of code where the array was allocated. If you pass it in as a parameter to a function, then you can no longer do that. I don't know what it's doing to calculate that. I mean, we could print out size of nums, you know, we can print out the individual pieces, but we just have to know that we can't do that. So that's why we had to pass the length in. Because in this particular language, you cannot ask the array for how long it is. Now we saw in Thursday's lecture that there's a for loop where you don't have to know the length. Beautiful for loop called a for each loop. However, that doesn't work inside of a function either if you're out of the context in which it is declared. No, I say that. I could be totally wrong. Let's find out. Let's find out. We're going to write something that prints out all the elements of an array using a for each loop. And we're just going to see if it works. Maybe this is going to be an array of strings, though. I'm tired of our numbers. So, public, wait, not public, void, because it doesn't need to return anything. Print underscore array, parentheses, string, AR, or maybe the whole word. We're not being charged by the penny, so array, string, array, subscript, in subscript, close parentheses. And now here's the syntax that we should be able to use to print the array. For, parentheses, string v or value, colon, array. And it's already giving me grief. The compiler's not even letting me try it. It says this range-based for loop requires a suitable begin function and none was found. Well, that's a lot less and more information than I want. Basically, I can't do it. I cannot use a for each loop or a range-based loop is what they're calling it here. I guess I better make comment of it. A range-based for loop is what I was calling a for each loop, which is what it's called in C#, C++, excuse me, in Java, or a value-based for loop in Python. So calling anyways, that doesn't work. We can't do it. We can't do it like that. So instead, if we were going to print the array, we would have to pass in the number of elements in the array. There are some ways we can get around that, though, by using something known as a reference. Now, Python and Java are known as pass by copy or pass by value, meaning that you're not getting the actual variable itself. Whenever you pass it into a function, you get a copy of it. But you could say, no, I really want you to be able to have access to the original memory that I'm indicating and not modify it, not change it. And I think I better lecture a little bit more about arrays before, but I really do want to mention references and pointers as well. So I'm not going to work that in. I guess we just need to do another example, maybe of, why don't we look at this line? That's what we're going to do. Have I broken anybody's code? Is your code no longer working because I started adding things? I broke Rochelle's code, didn't I? No, I'm kidding. All right, let's take a look. So using a loop to step through an array. Here's an example. Array size is 5. We declare an array of size 5. For int is count is equals 0, count is less than array size, count plus plus. Numbers subscript count is equal to 99. This will initialize every value in the array. It will set every value, assign every value in the array, every element to the value 99. So default initialization. In some languages, once you create an array, they're all set to 0. In this language, they're not. What do I mean by that? Let's make a new array down here, right before our system pause. Int more nums. And we want 10 of them. Now let's print them out. But let's use a for each loop, or a range-based loop. For int value colon more nums, in other words, for every value that's in the for nums array, curly brace, cout value, followed by a space, arrow, arrow, space, semicolon, and then after the close brace, cout, arrow, arrow, endl. And there we go. Well, boy howdy, that doesn't really look like useful data, and it's not. It's certainly not all zeros, and you might wish that when you created an array, it would all be initialized to 0, but C++ does not take the time to do that. Well, that sure is suspicious because it's the same value every time. Yes, because the Microsoft version of C++, if you're compiling for debug mode, fills every uninitialized element in the array with the same value to make it real easy to spot. However, the behavior of it differs where the array is allocated. If I allocated that array outside of any function, if I made it a global variable, if I cut this out and pasted it above main, now I'm not going to ask you to do this because I'll probably undo it immediately, but if I went up here and I cut that and I pasted it and put it above main so it's now a global variable and I run it, when I run it, they were all initialized to 0. So just because we moved it to somewhere, just because we made it a global variable changes behavior. All right, I didn't invent the language. I can't complain too much about that. But if you do want them to all be initialized to 0, we've seen the syntax for it. Do it like this. Just say equals curly brace 0. And what that does is it sets the first value to 0, and then all subsequent values, instead of being initialized to that weird 8 billion value that we were seeing, are also all set to 0. And again, if we change that to a 1, it wouldn't set them to 10 ones in a row. It's just that the first one would be a 1, and then the rest of them would be a 0. And as a matter of fact, we could prove that to ourselves. Inside your initialization list, type like 3 numbers in. 34, 55, 66, and then run it. And notice what the last 7 values in the array are as compared to the first 3. 34, 55, 66, all followed by 0. So the initializer list fills in up to the point where we stop giving it data. If we don't have enough data for it, then it just fills it all the way in with zeros. And so if we stick a comma, a 0 here, the first element becomes 0, and then the rest of them are all defaulted to 0. If we set it to a 1, the first element becomes a 1, and then the rest of them are all set to 0. So that's a nice, quickie little syntax to initialize the array to zeros. Why would you want to do that? Well, it's a real drag if you're trying to like add totals or whatever, and you have pieces of data that you're trying to add, and you're getting 8 billion added to it each time because we're using uninitialized data. Well, why might that occur? You can have what's known as a partially filled array. A partially filled array is when you've started adding data to the array, but you're not done adding data to the array yet, so it's not full. So like if we had a weekly sales array that was 7 elements long because there's 7 days in a week, and we asked them for the sales of Monday and for Tuesday and for Wednesday, yeah, the first 3 elements are going to have data, but Thursday, Friday, Saturday, and Sunday won't. So let's do that. Let's mention the idea of a partially filled array. An array in which not every element has data assigned yet. So let's do int sales, 7 days worth of sales, equals curly brace 0, initialize them to 0. Now let's make an array of day names, string days, subscript 7, or we could even leave the 7 off because we know how many days we're going to add to it, but equals curly brace, quote, MON, end quote, comma, quote, TUE, end quote, comma, WED for Wednesday, end quote, comma, THU, end quote, comma, FRI. I'm tired of typing, so I'm going to change this to a 5-day sales week. There we go. And after the close curly brace, a semicolon. So let's add, pardon me?
Change that string days to 5.
That should be 5 as well. You're absolutely correct. And what we really should have done is declare that 5 as a constant. If we do not define this, then it defaults to being the length of the number of elements in there anyways. So I think I'm going to just leave that off. I'm conflicted. I'll make it 5. Alrighty. So we're going to ask the user to enter the sales for that day. So we need a loop. Loop that's going to count from 0 to 4. So for parentheses int I equals 0, I less than. Let's ask the array how big it is. Say size of parentheses sales in parentheses divided by size of sales subscript 0 in subscript. So in subscript, 2 end close parentheses, and then a curly brace. So let's ask them, C out, error quote, sales for, end quote, arrow, days, subscript I, in subscript, arrow, quote, space, greater than, just to let them know that they're supposed to type there, end quote, semicolon. And now let's let them type it in. CIN, arrow, arrow, sales, subscript I. I seem to have an error here. I see a closing. Oh, I forgot to put I++ at the end of my for loop here. My for loop syntax is wrong. Right there, between the two closed parentheses, there needs to be a semicolon I++. So that's what I left off right there. Now, just to kind of prove the point that it's a partially filled array, I'm going to stick some debug code in here that's going to print out the contents of the array each time. We should make it a function. It's not gonna. So let's use a range-based loop, a for each loop, for parentheses, int value, colon, sales, into parentheses, C out, arrow, arrow, value, semicolon, and then the next line, C out, arrow, arrow, E and DL. Let's just start debug printing of the array elements. About the fastest possible way, or shortest to write. All right, so sales for Monday, $100. Sales for Tuesday, $200. Sales for Wednesday, $300. Okay, now this is dumb because look what I did. I forgot to put spaces in my output here. So I'm going to go back to my little for print statement here. And where I say C out, arrow, arrow, value, semicolon, I'm going to insert before that semicolon another less than, quote, space, quote. So I just modified that. This is now our printing loop. We really should make that a function though. So we can print out the array anytime we wanted to. Okay, so right now, sales for Mondays, 100. All right, and look, we have 100, but the rest of it's filled with zeros. 200. Now we still have 3 zeros left that haven't been filled in. 0. Okay, well, that may be legit. And then 200. All right, so Thursday we had 200, and then Friday, 999. Okay, so if we were looking at this array at any point before we had it completely filled, we wouldn't know whether a 0 meant data that hadn't been set or whether it was really a day of no sales. So if we were going to calculate the average, we wouldn't be able to do that. We wouldn't know how many days, right? What if I tried to calculate the average after entering only 2 days worth? Is our average sales 100 plus 2, is that 300 divided by 5? No, I only worked 2 days. Why am I being average for 5 days if I only have 2 pieces of data? So that's what's known as a partially filled array. And to work with a partially filled array, you have to keep track of how many numbers, how many pieces of information you have saved in it. So each time we go through here, we might be adding 1 to it in order to indicate that that's how many values we have in our array. So the problem with a partially filled array, you don't know which items have good data. Just because it's 0 doesn't mean it's bad data. 0 is a valid value, right? So, and yeah, you could try to do some kind of trick where you initialize it all equal to -999, and then when you're processing it, you check. What you got to do, though, is what you really have to do is to keep track of how many pieces of data you have in there that are valid. Now, in this particular case, since we're going from beginning to end, we know how many pieces of data are going to be in it by the time we're done. It's going to be 5. But what if it was one of those things where it says, you know, enter test score or -1 to exit? Well, if they enter -1 before they've entered all 100 test scores, then again, we don't know where the good data begins, where the good data ends, and the null entries begin. I think I want to let that percolate in the brain while I go to the slide. Any typos anybody wants me to look at?
Yeah.
I'm gonna have to watch this lecture though.
Uh-huh.
All right. So as mentioned, if an array is a global variable, all the elements get initialized to 0. If the data is local, then they are not all initialized to 0. And we could prove that to ourselves by changing it not to compile in debug mode, but to compile in release mode by doing that little pull down, rebuilding the application, running it without debugging. And maybe they are initialized with zeros. It sure does look like it, but you can't guarantee it. Oh, that's because I have that equals curly brace 0 in there. I'm going to take that out temporarily. And there they are. If we were trusting those to be zeros, and instead there were that series of numbers, that's just whatever's in the memory contents at that particular time, right? When we said we want an array of 10 spots, we said, okay, you have enough memory now to hold 10 numbers, but it didn't do anything with those numbers, what was already in the memory. It didn't wipe them out or anything. That's why we have that cute syntax for setting everything equal to 0. So there is no bounds checking in C++, meaning that if you try to read an element with a negative index or an element with an index equal to or greater than the length of the array, it's not going to stop you from doing that. Which can create real problems. Let's create just a simple little itty-bitty array of 5 pieces of data, and then we're going to try to access more than 5 pieces of data in it. So maybe they're going to be doubles, I don't know. I better set it back to debug mode to make sure that I'm seeing exactly what you see. So double DAR for double array. Subscript, in subscript, subscript in subscript, square brace in square brace, equals, curly brace. Just type in some numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. We better get the size of that. But I'm going to pretend that I'm a dummy and I don't know how many elements are in it. I'm going to print out 100 elements starting with the first element. So for parentheses int I equals 0, I is less than 100, I plus plus, cout arrow arrow dar subscript I, arrow arrow quote space quote, semicolon, and then print out our carriage return at the end, cout arrow arrow PNDL. Okay. There is some kind of data, but there's not. There just happens to be some memory contents past that point, but it's not data that we should be accessing. It kind of has a look of that kind of default data that that we saw the debugger throwing into an uninitialized array, because I see the same values repeated over and over, but not every single time. In fact, I'm not sure that that's true. I'm not sure that I'm seeing repeated numbers, or my eyes are just being, eyes are crossing.
It looks like it needs an extra sys. I don't know what's going on with that.
Yeah, so what's happening is it's reading past the end of the array, which you can't do in Python. Python will throw an exception if you try to ask something past the end of the array. You can't do it in Java. Java will do the same thing. Java will complain most vociferously if you try to do that. So when we have an array, I know we have a picture of one somewhere. Right?
Talking about like a grid array kind of thing?
I thought we had a picture showing, well, I guess this would do. Here we have an array of 3 elements. So we said, yo, operating system, I need some memory and it needs to be long enough to hold three doubles. So it does that, it gives us 2. But then we say, okay, now I want to know what the value of the 4th element is. Whatever's in RAM there, it goes ahead and tells you. It's just not data that you should be accessing. Same if we started using negative indexes. We could go back there and we could read data that was out of bounds of our arrays. We're reading parts of the memory that we should not read. And as bad as that is, it's far worse if you're changing those values. And I think I demonstrated that last time, to where if we start changing the values outside of the edge of the array, then the debugger will probably catch it and stop the program from running. But that's because we're running in debug mode. If we were running in release mode, then the debugger is not trying to stop us from doing that at all. So it does not do bounds checking, meaning you need to make sure that you don't read past the end of the array, which is why we do things like that size of business to get the length of the array out. Because we really only want to print out, right, the number of elements that we really have. So int dar underscore size equals size of dar in parentheses divided by size of dar subscript 0. And you see why we're doing this second one, right? This is just to get the size of that element. Now we know what kind of element it is. We could replace that dar subscript 0 with the word double, and it would work just as good. But then later on, if we change this to a different data type, like long or whatever, we'd have to change this one as well. Whereas if we leave it the way it was, just tell me the size of the first element in the array, then it doesn't matter what type it is, it's still good code. So dar subscript 0. All right, now we're not going to see the exorcist anymore. We're not going to see all this stuff. When it runs, it's going to stop and print out the values. Oh, good grief. Well, I said it wasn't. Oh, that's because I didn't. What did I do? I made this change here so that it would stop at that, but then I forgot to make another change. In the for loop itself, we need to refer to that length variable, dar underscore size. All right, and then it printed out the contents of the array. So be careful not to use invalid subscripts because it can corrupt memory locations or crash your program or lock up the computer and cause elusive bugs. An off by 1 error is when you try to use a subscript that is invalid by 1. For example, if the size of our array is 100, and so we try to print out elements 1 through 100. Well, that's not going to work. If the array is of length 100, we can print out elements 0 through 99. And so trying to do it as though it were 1-based indexing rather than 0-based indexing gives you an off by 1 error. So here's an example of using the initialization list. We're going to fill in this array with these specific 5 numbers. If this size declarator here is smaller than the initialization list, it'll give you an error because we're trying to copy 5 elements into like a 4-element array. But the opposite's true. It's okay for the size to be larger than the length of the initializer, and if it is, they all just get set to 0 after that. So if an array is initialized with fewer initial values than the size declarator, the remaining elements are set to 0. So we have an array here called numbers. It's set to 7, and we initialized it to the values 1, 2, 4, 8. Well, that means that the first 4 values are set, but we didn't give any initial starting values for the other 3, and so they just defaulted to 0. The array, if you leave off the size declarator, it can do implicit array sizing, which is where that's picked up from the number of elements in your initialization list. In this case, we have 4. And so if we leave off the size declarator, then it creates an array exactly large enough to hold those 4 values. So a range-based for loop is a loop where instead of using an index for I is equal to 0, I is less than the length of the array, you step through the items by their data type, by their value. Now there's some warnings. This was introduced in C++11, meaning the version that was ratified in 2011. So it's actually a fairly new thing, relatively speaking. Well, that was 8 years ago. Yeah, but the C++ language has been around since like 1980. So it's a relatively new thing. Not every version of C++ has been updated to the 2011 standard. So if you're not using Codebase, whatever the Mac version is, the Mac one is called, is it Workbench or Codebase? I don't remember. Or if you're on the PC and you're using Microsoft Windows, then I'm guaranteeing that you've got access to it. But there may be some compiler that you're using. If you buy yourself a Raspberry Pi and you want to write some cool program that'll load your Nintendo games on your Raspberry Pi, it could be that the compiler is not the most modern one, and for each loop, a range-based for loop is not going to work. So each time the loop iterates, it copies the element from the array into a temporary built-in variable. So if your array is called array, then the syntax is like this: for data type space range value colon array. So when we had an array of nums, our data type was int, and this is how we made it look. For every integer value in the nums array, do something. It's a much cleaner syntax. If we have 2 ways of printing something out, and you can get away with using a range-based for loop, I would do so. When can you do that? If you're in the same context in which the array was allocated. So here's an array of numbers stored in an array called numbers. So the array name is numbers, the data type is int, and so here's a range-based for loop, a for each loop for printing it out. For int value colon numbers. Print out that value followed by E and DL.
So then if you had like if you had a function that returned, I guess, whatever, you couldn't use the range-based for loop for that, right? Because it would be like...
Yeah, if you try to pass this array into a function and then try to use a range-based for loop inside that function, it's not going to work. Yeah. So I want to switch gears and talk about references and pointers for a moment. And even those of y'all who are hurriedly working on your homework rather than following the lecture, I kind of want you to see this. If we define a function and we wanted to change the value of something we pass to it, it's kind of a problem. And this is not true just of this language. It's true of Java, Python, whatever. So for example, I'm going to make a silly function called foo, F-O-O. And it takes a variable, int x, and it sets the value of x equal to 99. And down here in main, I'm going to declare an integer, and I'm going to pass it to the foo function, and then I'm going to print out the value of the integer afterwards. So int mynum equals 0, mynum subscript, foo subscript mynum, and let's print out mynum. Cout arrow arrow quote mynum arrow arrow quote arrow arrow mynum arrow arrow endl. And I'm just going to put a system pause here because I don't want to see the rest of the code at this point. If you're on a PC, if you're on a Mac, that's not going to work. All right. It printed out 0. I wanted it to print, well, I thought it was going to print out 99. What happened here? We passed this variable in, mynum, as an argument to fill in this parameter variable here. but it was passed in by copy. It was passed in by values. Like I made a photocopy of my dollar bill and I gave it to you. It doesn't matter if you crumble up the dollar bill or burn it, I still have the original one. X here is just a copy of the 0 that was passed in. And so even when it changes it here, it does not modify the value of my num at all. However, you can do something known as pass by reference. Pass by reference looks like this. I'm just going to call it void foo2. The way you define a reference variable in this language, and by the way, Java and Python do not have reference variables in this same capacity, reference parameters, is you put an ampersand there. We're saying this is not an integer copy, it's a reference to the original data. And so now, I don't know why I put R there. Why not? Because it's a reference. Nah, I'm going to make it X anyways. X is equal to 88. So now when we come down here, if we called foo2 num rather than foo num, it actually will change it. So it did change it. The ampersand, this is an example pass by reference. X is not a copy of the parameter of the argument that was passed in. X is the variable that was passed in. X is a reference to the argument. It is the argument. For all intents and purposes, whatever you do to this variable happens to this variable. They are one and the same. They are linked by the fact that we pass it in like that. There's another way of passing data in known as pointers. I'm going to show it to you really quickly, and then we're going to talk about pointers again in another lecture. The way that looks is like this. Void foo3. You do ampersand. It's not ampersand. You use an asterisk. And I'm going to call it px there. Just accept it on faith. And then I'm going to say px equals 77. Like that. What this is saying is I'm not going to pass you an integer. I'm going to pass you the memory address of the integer. And then he's allowed to change it because he knows the address. Just like if I write down my home address on a piece of paper and give it to you, even though that piece of paper is a copy, you have my home address. You can go and break my windows if you want. So we're passing in the address of whatever variable it is, and then this code can go out and we can modify it. And that's what the syntax means, which we'll explain in more detail next time. Change the value at the address stored in the pointer to 77. But we do have to change the syntax in order to get that to work. We have to do something like this. Foo3, and then to pass a pointer in, I can't just do my num. I have to turn it into a pointer by putting an ampersand in front of it. Pass the pointer to the my num variable, to the function. Won't necessarily make sense the first time you see it. The idea of the reference is actually easier to get, I think, right? You just put a special symbol here and all of a sudden it's able to pass data in and out. Any changes made to X inside here modify the original data. Doing pointers is a level of abstraction that we'll talk about one more time. All right, why don't we stop? You could also wind up taking the array quiz actually in the quizzes section. But for example, here we have a 4-element array. The first one says F-150, the second one says Corvette, the third one says Citation, and the fourth one says Model T. What is the substring of the element Model T? So is it, what is his index number? Well, what's the index number of the first element? 0, 1, 2, 3. So we put in 3. And then what is the index number of the F-150? 0. And then what is the length of this array? Excuse me, what is the size of the array? If we did size of array, what is it going to tell us? Well, each byte is 4 bytes long. And how long is it? It's 5 elements long. Each element is 4 bytes, so 4 times 5, 20. And then what is the length? 1, 2, 3, 4, 5. And then declare an array called numbers. It is of type double and has 3 elements. And then store element 3.1415 into the last element of the array. I'd expect that by now that we've had a couple lectures, you ought to be able to do that. So that's the homework assignment.